All right, so we're back in, and we're going to talk about cubes and cube roots now. So we're moving on. So just like last time, let's start with a little review of the most basic parts of it, right? So what is cubes? What are we talking about when we talk about cubes? We're talking about a number to the third power, right? So this would be n to the third power. What's another way to say it?
Jeff, is that a negative n?
No, sorry, it's just a dash.
Okay.
Or a bullet. This is also n times n times, times n, right? And what's our fancy way to say it? N cubed, right? So if I take a number, any number, right, like 2 to the third power, if I can, guess I'll call this example 1. That's the same as saying 2 times 2 times 2, right? 2 times 2 is 4, times 2 is 8. What is it absolutely not saying? 2 times 3. We're not doing 2 times 3, right? No, don't do that. 2 multiplied by itself 3 times is 8. How do I do this in the calculator? Let's do example 2, and we'll do 13 cubed. Okay. So for this one, I type the number first. So I'm going to hit 1, 3, and then above the squaring key is a key that I call a caret. So we're going to hit that, and then we're going to hit 3 for the third power. You know, that'll be our cubing. 13 to the third power, hit enter. And what do we get as an answer? 2,197?
Yes, sir.
Put a lot of trust in you, Ryan. You better be right. Okay, so that's what cubing means essentially, right? So now I'm going to go back. I'm going to clear this if that's okay. And let's talk about cube root now. Just like before, okay, I'm going to say that, what if we, I'm going to just start with an example here. But before, like if we say square root of 2917, that was it, right? Up, dyslexia. 2197, like that. Sorry. That means what number times, cubed root, not square root, cubed root. So the symbol for cubed root is this, right? That's the symbol. Sorry, I should have started there. If I take the cubed root of 2,197, that means what number times itself one more time equals 2197. And we know from what we just did that that number would be 13, 13, 13, right? So what number times itself 3 times gives me 2197. Okay, that's what cubed root means. So square root means what number 2 times, right? Whereas cubed root means what number 3 times multiplied by itself, okay? Third root. So if I do another example, one for first example for cubed root of 64. Let's think about what that means, right? That means what number multiplied by itself 3 times is going to give me 64. But you can type this into your calculator, right, too. But if you could think it out, anybody know what it is? Oh, okay. Ryan says 4 times 4 is 16, times 4 is 64. So the cubed root of 64 equals 4. Very good. But how do I type that into my calculator? Because I really want to be able to use that tool, right? This one's a little bit harder. It's harder to remember this. So first we have to hit what root we're going to take it to, because we can do the 4th root, we can do the 10th root, right? We can do the 25th root. We're not going to, but we can, okay? So we have to tell it what root we're going to go to. So very first thing we're going to do is hit 3rd root. We're going to hit 3. Then you're going to hit the 2nd button. Then you're going to hit the caret button, because if you look above the caret, what do you see in green? You see a little root symbol with an X, right? So 3 is going where X is, right? And then we're going to type in our number, which was 64, right? And then we could hit enter. And we get 4, right? You're likely never going to have to take the cube root of something without a calculator. So you got to practice this maybe so that you remember, because this one I think is not as easy as some of the other ones. You have to start with the 3, which is kind of confusing, right? Okay. Let's talk about some problems where we might see cubes and cube root, okay? So maybe we'll be given a picture, right? So this will be practice. I'm just making this up as I go. Obviously, it's always different every time. Imagine that we have a cube, right? We know a cube, all sides are the same. All the edges, right? This would be an edge. All the edges are the same in a cube, okay? And they might tell us that our edge of a cube is equal to 5. We'll say inches, right? And then they might ask, what is the volume? Because when we deal with 3D figures, it's always volume. Or it could be surface area, okay? But right now we're thinking about volume. So how much water can I fit into my cube, for example, right? So if you were bored at an office job, okay, imagine my cubicle is a cube. How much water could I fit in? Okay, so, like Jeff, stop. Your jokes aren't funny. Nobody laughs. Okay, so we learned that, so if you look on your GED formula sheet, you're going to see a right, what is it called? Does anybody have there? Anyway, I can't remember what it's called, but it's going to say volume equals length times width times height. And in this case, that's just edge times edge times edge, length, width, height. So we can say for our cube, volume is edge to the 3rd power. Okay? 5 times 5 times 5, essentially, right? So if I need to find the volume, I'm just going to say volume of my cube is equal to edge to the 3rd, or 5 to the 3rd, right? I could type it into my calculator, right? I just have to hit 5 caret 3, and you'll get 125. What is my label? Volume equals 125 inches to the 3rd, inches cubed. Because when we did 5 cubed, we did 5 inches cubed. 5 inches, right? 5 times 5 times 5 is 125. Inch times inch times inch is inch to the 3rd. Is that what it says on their formula sheet, rectangular prism? I think so, yeah. So this is the formula for rectangular prism, the volume. Okay. So there's an example of something we might see, right? Here comes another. Practice 2. It's a science here. This time they might say a cube has a volume of, let's see, 512 cubic feet. The question might be, what is the length of the edge of one edge? So this time they gave us the volume, we have to find the edge. So we go back to our formula, right? Because if they give us the volume, we're going to use the volume formula. We use for a cube, we use volume equals edge to the third power, right? We know the volume, they told us, right? They told us the volume of our cube. And that was 512. And that's equal to edge to the third, right? Now what do we have? We have algebra. It always comes back and finds us, right? I don't need to know what edge to the third is, right? I need to know one edge. So I need to get from edge to the third to edge. What's the opposite of cubing something? Cube root. These are opposites. And in algebra, right, I always say, what's the opposite operation, right? That's what we have to do to get it by itself. So here we're going to take the cubed root. And if I do it to one side, I have to do it to the other side. So I'm going to take the cubed root of 512. Again, on the calculator, I have to hit 3 first. Then I hit second. Then I hit the caret, because above it is that little, right, symbol. And then I type in my number and hit enter. And we should get 8, but we better label it because I want to know the length, the distance of it. 8 what? 8 feet. So if I had my cube, I know that one edge right here would be 8 feet. All right. Any questions on anything to do with cubes and cube roots?
You're good.
All right. So let's jump over to, let's start doing some data analysis stuff. So we're going to do mean, median, mode, and range. Okay. I'm going to start with mean. Mean is a synonym, means the same thing, synonym for average. Okay. And so I'm just going to start with a little, I'm going to draw a table, and maybe we'll use the same data for the whole time. So why don't you guys draw this with me? What should our data be about?
Means the number of students in class.
Wait, what?
Number of students in class.
Great, thank you guys. You guys were ready. So number of, I'll just say S's, students in class. Okay. And Homer, how many of you are there today?
2. 4.
How many?
4.
I'm going to say 4. Juno, there's 3 of us.
2 students, 2 teachers.
Oh, okay. Oh, yeah, I guess we're saying students. So there's 2. There's 2. Kodiak, how many we got?
1 student, 1 teacher.
Okay. And Barrow. I saw Barrow's chiming in. Thanks, Barrow. One of us in Barrow. Okay. Ooh, this is an interesting one. I'm going to, just for fun, and just because I'm thinking ahead about the math problems we're doing, I'm going to pretend that Bethel's here. And I'm going to pretend that Bethel has 5 students. Okay. You guys are like, oh, you're messing up the data. This was real. Okay. So how do I find the average? We talked about it a little bit earlier, right? What we do is we add. So if we were talking about steps here for mean, we add all the data together, and then we divide by the total number of data pieces. So here we'd be dividing by the total number of sites, right? And how many sites are here, including one fiction? There's 5 total sites, right? So if we're going to find the mean of the students in class today, what are we going to do? We're going to add up all the numbers, all the data. 2 plus 2 plus 1 plus 1 plus our fake 5, right? 2 plus 2 plus 1 plus 1 plus our 5. Divided by, whoa, didn't mean to do that. Divided by, how many sites are there? 1, 2, 3, 4, 5. Okay, that'll give us our average number of students today. And you could just, what I would do if I were doing this on my calculator, to be honest, I would just add up all the numbers first. So I'd hit 2 plus 2 plus 1 plus 1 plus 5, and then I hit enter. And the answer is 11, right? And then I would leave it there, and I would just hit divide. And then what's going to show up on my screen is answer divided by 5. And I get 2.2 students. That's the average number for today. Divided by 5 on the top number. Yeah. And so what's the real average for today if we get rid of Bethel? What's the real average? Students per site, the real average would be 2 plus 2 plus 1. Whoops, sorry. Divided by 4, and we get 1.5, right? Okay. All right. So that's average. Now we're going to talk about median. So go ahead and write down median. This takes a while, so I want to keep our chart up there. Should be a better way, but there's not.
Michelle loves your eraser.
All right. Thanks, Michelle. All right. Let's talk about it. Median. Whoops, I'm erasing stuff. Here we go. Get it together, Jeff. Median is the middle, right? Median, middle, median, middle. Okay? And what we have to do is we have to put them in order, right? From smallest, the least, to the biggest. So for our data set, right, I'm going to say, okay, I'm going to start with the little 1, 1, then 2, 2, then 5, right? And then I just cross out until I have whatever's in the middle, right? I take it off my ends, take 2 more. So our median equals 2. Sometimes we have 2 numbers in the middle though, right? So let's pretend that Sitka is here and they have 3 students. Okay, so we're pretending again. And so I'm going to do my data again in order. 1, 1, 2, 2, 3, and 5. So this is if Sitka was here, right? So I cross off from the outsides. And now I'm like, wait, I got 2, right? I got 2 in the middle. So what happens when we have 2 in the middle? So if there are 2 in the middle, we have to find the mean. Okay? If there are 2 in the middle, we have to find the mean. In this case, we have 2 and 2, right? I'm going to take this over here so I have some more room. 2 plus 2 divided by how many pieces of data? Well, I just added up only 2 of them. You see, there's only 2 of them that I'm using. 2 plus 2 is 4, divided by 2 is? 4 divided by 2? Yeah, you got it. 2. So for this one, again, my median would equal 2. But I have to take the average of the middle 2 because there's an even amount of data this time. This time there was 6 pieces of data, so I had 2 in the middle. This time there was only 5, right? So if it's odd, I will have just 1 in the middle if I have an odd number of data. Yeah. So that's our median for this problem, okay? The middle number. Michelle's excited. Here I go again. Next, we're going to talk about mode. Who remembers what mode is? Mode means what happens Anybody? Sometimes I feel like I'm talking.
Most.
Yeah, thank you. Mode means most. Go ahead, write that down while you wait for me to finish this racing. Mode means most, right? So what happens the most? In our data set, and it can help if you put it in order, I think, because you see which ones repeat. In our data set, we have 2 numbers that repeat. So we're like, what's the mode if we have 2? Can you have more than 1 mode? Yes. So the good thing to remember is you can have, I'm going to write 2 things here. You can have more.
You could also have no modes.
Great. That's the other thing I was going to say. You can have more than 1 mode, or you could have no mode. Thanks for your help. But in this problem, it's a case where we have more than 1, right? What's our mode in this problem? The mode is 1 and, whoops, 2. Can you show us an example where there would be no mode? Yes. So Ryan here in Juneau wants to know, can I see an example with no mode? So here's an example for no mode. Imagine our data. Let's imagine, if we look up here, that Barrow's not here. Sorry, Barrow. And that Juneau's not here. We would just have the data would be 1, 2, and 5, right? Is there anything that happens the most? If this was our data, nothing happens the most, right? So in this case, there would be no mode. Where here we have more than 1. Okay? Any questions on mode? Last time.
Hey, Jeff.
Yeah.
So if you were able to do that in a circle and then press in the middle, would it just erase completely for you?
You know, that's how it works on a smart board, and I love that, but it doesn't seem to work on this.
Okay.
But thank you for the suggestion. That would have been exciting. All right. Good suggestion. Last one. Range. Range is fairly simple. We take our biggest data number and we subtract our smallest, and that gives us the range. So when we do range, we subtract. So if Bethel were actually here with 5 students, that's our biggest, right? So we just plug in 5 minus our smallest, which are Kodiak and Barrow, 1. So the different range between one site to another for number of students would be 4 students. That's our range.
For mathematics formula sheet and explanation, it only says mean and median. Would we be allowed to write?
Question is, I only see median and mean on my GED formula sheet. Can I write the other ones on there? Quick answer to that one is no. Can't write other extra stuff on there. That would be awesome. I had a student the other day, or a couple weeks ago, joke that he was going to get a tattoo of like formulas on his arm that weren't on the formula sheet. It's like, what are they going to do? Yeah, pretty good idea, right? But no, you just refer to the formula sheet for those formulas, but for mode, most, right? Just remember, range you have to subtract, okay? Any questions? Okay, probability, last section. There's kind of a few different kinds of probability problems we looked at. One is talking about the kind of question that's like, how many combinations of something can we get? And so let's just look at an example. How many combinations can we get if, let's say we're at a restaurant, right? And there's an appetizer, right? There's a main course and a dessert. Okay, on the menu, you have 5 different apps, you have 3 different mains, and there's 2 different desserts. How many different combinations of dinner could somebody order? Okay, and all we have to do here is multiply. There's 5 apps times 3 mains times 2 desserts, so there would be 30 different combinations. Another problem would be like when we talked about independent versus dependent probability problems. Independent is when the first result and the second result aren't really connected. So we might say we have, so we're going to go over independent types of probability problems where the results are independent. So here's an example. You have 2 die. You are rolling, right? What are the chances that you get chances you roll a 1 on the first and a 6. I'm having a hard time here. 6 on the second die. Sorry, sloppy. So you have 2 die. What are the chances you roll a 1 on the first and a 6 on the second? Okay.
Assuming you already rolled.
Yeah. So the first one we're going to roll, and we're hoping to get a 1. What are the chances that we get a 1? It's 1 out of how many sides are there?
Oh, 6.
There's 6 sides. So one of the sides is a 1. That's our event that we're looking for. The total possibilities, right? So we always have the event that we're looking for over the total number of possibilities. So with a die, we know we have 6 if they don't say, right? They could say you have a 12-sided die, but we know, we've talked about it, it's always 6 if they don't say. And then what about rolling a 6 on the second die? The chances would also be 1 out of 6. So what would my total probability be? I have to multiply, right? And when I multiply fractions, it's pretty simple because I just go straight across. 1 times 1 is 1. 6 times 6, or 6 squared. Oh, it's coming back. 36. 1 out of 36 chance. Okay. What if I said, give me your answer as a percent? Oh, Jeff, come on. So you just take your calculator and type 1 divided by 36, enter. 1 divided by 36, enter, and you get 0.0277, right? To change any decimal to a percent, that's what I asked you for, right? To change to a percent, you move the decimal 2 spaces. Move the decimal 2 spaces to the right. So I'm just going to take this decimal and move it 1, 2, and so I get 2.7, and it's going to, that's another 7 there. So it's going to be 2.78. I round up. 2.78. This becomes an 8%. So I have a 2.78% chance of rolling a 1 and a 6. A 1 and a 6. Okay. You could also see the answer written like this, 1 out of 36, like when we did our Kahoot today. Okay. So fraction, percent, or ratio. This is called a ratio. R-A-T-I-O. That's a really ugly arrow. That's ratio. And that's a really bad joke. Okay. So let's talk about a dependent example of probability. So right now we're going to talk about, here's our example. You have a deck of cards. What are the chances of pulling out 2 kings? Right? What are the chances of pulling out 2 kings? And it might say this keyword or key phrase, without replacement. That means we're not going to put a card back in the deck when we pull it out, right? We're going to pull it out, and then we're going to pull another one out, okay? So let's imagine we're starting our experiment here. How many cards are in a deck of cards? 52. They'd probably give you that information, guys. You don't have to know that. Okay. 52. And so when we are going to try to pull one out, how many kings are there? There's 4 of each suit. Okay. So again, you wouldn't have to memorize this. They'd let you know that information. Not everybody is that familiar with cards, right? But there's 4 kings. So we're trying to see how many kings we can pull in a row, right? Out of how many cards? 52. Okay? That's our first time we're pulling a card out, right? The second time we pull a card out, how many cards are in the deck? 51. Because we already pulled one out. And it was hopefully a king. How many kings are left the second time? If the first time we pulled a king, how many are left? Now we're down to 3 kings left because we already pulled one, we're saying, on the first try, right? Out of how many cards? 51. So that's probably the most confusing thing. We already pulled a king here, we're pretending. So how many kings are left the second time? 1 less. 3. Out of 1 less card too, right? So what's my total chances? Well, I have to multiply this. 4 times 3 is 12. And 52 times 51 is 2, 6, 5, 2. I am not done. Because 12 and 2,652 definitely have a common factor. I know they're both divisible by 2 because they're even. Oh, look at that. We learned this, right? They're both divisible by 2 because they're even. Are they both divisible by 3? Let's see. 2 plus 1 is 3. Is 3 divisible by 3? Yes. 12 goes into 3, we know. Or 3 goes into 12. Does 3 go into 2,652? Remember, I add up all the digits. This is a review from an old lesson. 2 plus 6 plus 5 plus 2 equals 8, and 7 is 15. And 15 is divisible by 3. So is this. So they're both divisible by 3 as well. I just wanted to review that. But really what we would do if we had a calculator, I'm going to show you that. How would we simplify this if we had a calculator? Well, you're just going to hit the fraction key, which is n over d, right? Then you're going to type in the top number, 12. Then you're going to scroll. Remember this button, the one that looks like this on the top right? You're going to scroll down. And then you're going to type in the bottom number, which is 2652. So scroll down, and then 2652. What do we get? 1 over 221. So this simplified would be 1 over 221, and that's how you might see the answer choice A. You're not going to see this because they're going to have it as a simplified answer, okay? If I asked you for a percent, what would you hit? You'd hit the toggle key. Looks like this, it's right above enter. And that would give you the decimal point 0.00452. Percent, we move 2 to the right, so it would be 0.45% chance. Not a very good chance, so don't bet your money on pulling out a pair of kings. 2 in a row. Okay?
Is there a simple way we could write that down? Like this for how many, for probability, how many combinations, multiply by variables, and independent variable, right? As event divided by number of possibilities.
Mm-hmm.
There's no simple way.
There's no real simple way to write that, to write this sort of process, but good question. Yeah. Okay, so that is basically the last 4 lessons condensed into an hour, right? Wow, I did it. So bye, Kodiak. Thanks. So if you guys have a chance to practice do the practice problems, do that, and then I'll post the YouTube video online of me going over the practice problems so you can watch that, okay? So what I'm going to do now is I'm going to pause and give you guys time, if you can, if you have time to stay and work on it, to try the practice problems. And they're mixed up, but they're all similar to what we did today in practicing. The first one's fun. It's a real world data analysis. So we're looking at the PFD, the individual payout by year since 2010. We're going to find the mean. We're going to find the median. We're going to find the mode, the range, right? All those things. And so go ahead. There's 5 total problems, and then there's a challenge question. Not as hard as the other one the other day, Michelle. So go ahead and try those problems, and then we'll come back. Or you could try it one at a time if you want to do problem 1 and then say, hey, Jeff, can we go over it? That's fine. But this could take a while, I understand. So if you guys can't stay on the line, I can just go over these later and record it, the answers on my own, and then post it to YouTube. So you just let me know what you're planning on doing. I'm going to stop the recording or pause it for now. Okay, so we're back in the recording. We're going to go over problem 1, which was all about data analysis with the PFD, right? 1A. What is the mean PFD payout from 2010 to 2007? So that means we have to add up all the numbers and divide by the total number of data, right?
Yep.
Well, what we would have is a fraction, 1281 plus 1174 plus 878 plus 900 plus 1884 plus 2072 plus 1022, and lastly 1100 is what was given this year. And how many data points were there?
8.
8. And then when we plug that into our calculator, what do we find is the mean? 1311?
103111. And then 3 ones.
Is there a change? Oh, I see. That would, let me grab the calculator really quick and check that out. Is that average? That wouldn't make sense. That could be the total. Oh, that's the total.
Yeah, that's total.
Okay, I was confused. That's the total on top. 111.
Yep.
Right?
Mm-hmm.
Or is there too many ones there?
No, that's perfect.
Well, I'm going to add them up really quick. I'm
No problem.
myself. 878 plus 900 plus 1884 plus 2072 plus 1022 plus 1100 is, yeah, on the top we got 10,311 total dollars over 8 years.
You didn't get a third one?
I didn't.
I got a third one.
And it wouldn't make sense, right? This wouldn't equal 100,000,
Right.
right? It would be more like 10,000.
Right.
So divide by 8, and we find the average would be $1,288.88. Round up. So that's our mean for problem A. All right, so let's clear that. And let's look at problem B for number 1. What is the median PFD payout? So for this one, I'm going to put them all in order. The lowest is 878, right?
Right.
Followed by 900. Followed by 1022, right? Yeah.
Yep.
Followed by 1100. Is that correct? Yep. Followed by 1174.
Then
What do you have after that?
1,281.
1,281. And then
1,884.
1,884.
2,000. 2,072.
2,072. That would have been nice for this year.
Right.
And so then to find the median, we cross off from the outside. So get rid of one pair, get rid of a second pair, get rid of a third pair, and we have two left, right?
Right.
We have two left. We have to find the mean of those two. So we're going to add these two and then divide by 2. And that's going to be our median. 1100 plus 1174. Get my answer. Divide by 2. 1137. That's what we should have got for the median, right? And we know it's in dollars. Good there?
Yep.
Cool. All right, let's look at problem C. What is the mode of PFD payouts since 2010? What did you guys say for that?
I got 2,072.
So the mode means which one occurs the most, not which one is the biggest.
So no mode?
So it's no mode because no number happens more than once.
Okay.
If there was another payout, let's say in 2009, right? We had more data, and in 2009, there was $900 payout.
Right.
900 would be the mode. Okay. Part D. The largest ever PFD payout was in 2015. The lowest ever was in 1983 when it was only $386.15. What is the range in PFD payouts since it began in 1982? So we have to think about, okay, what do we do for range? The range, we take the biggest number minus the smallest number. So the biggest the PFD ever was 2015, 2072.
Which we need again.
Which what?
Which we need again.
Yeah, right? Subtract the smallest ever, 386.15. That gives us our range. So we do 2072 in our calculator minus 386.15 equals. So the range in dollars from the smallest to the biggest, so that this is the difference between the smallest and the biggest. So we can be thankful that our PFD wasn't only $386
Right.
like it was in 1982. All right, that's D. Lastly, we'll go over E. Oops. Imagine the state investors set a goal of averaging a PFD payout of $1,400 from 2010 to 2018. At minimum, so what would the PFD have to be at minimum in 2018 to reach that goal? We have to imagine that we're adding a column to our chart, right? 2018, and we want to know what would that have to be. Oops, that should be a question mark, not a 3. What would that have to be for our average or for our mean to be 1,400? Okay. So remember when we added up all the numbers, what was our answer? It was 10,311, right?
Yep.
So if we add up all the numbers, we get 10,311, right? But we have one more year, right, that we're going to include for this mean. So this is a mean. We have to find the mean, right?
Right.
But we don't know what that is yet. So we're going to call it X. So our question mark, X. Divided by how many years from 2010 to 2018? 1, 2, 3, 4, 5, 6, 7, 8, plus that next extra year, 9. And we want it to equal 1,400. Okay. So what we have here now is an algebra problem where we have to solve for X. When we solve for X, we'll know what we would have to earn for our PFD in 2018 to average 1,400 over those years. So this one we didn't quite go over in class, but we did talk about it in the past, right? And so how do I get X by itself? The first step is I have to get rid of this division because it's kind of locking these together. So I can't just subtract this big number because it's locked in by this big division sign. So what I'm going to do is the opposite of division and I'm going to multiply, that's the opposite, by 9. 9 over 9 cancels out. Those cancel out, okay? And then multiply by 9 over here, because I have to do it to both sides. And I get 12,600. And then I have left over here, like that, right?
Right.
So now I'm back down to one more step to solve my algebra problem. I have a positive 10,311 and I want to get x, I want to get x by itself so that I know what it equals, right?
Right.
So I have to get rid of this. It's positive right now, so I have to take it away from this side to make it go away. If I subtract it from one side, I got to subtract it from the other. So minus 10,311. And then that tells me what the PFD would have to be in 2018 so that we could average for that period $1,400. So that's what the PFD amount would have to be in 2018 to have a 1,400 average. Okay, make sense?
Yep.
Cool.
It'd be the highest we had, right?
Yeah, would be the highest one. We'd have a new high if we had. We'd have to find a new range, right? Okay. So I'll just go off again, and then we'll return to if you have a question about problem 2.
Okay.
Okay, so we're back. We're going to go over number 2. In the practice problems, imagine you're trying to build a shed with a square interior. I'm going to draw a square, right? If you wanted the space to be exactly 225 square feet, what would the perimeter of the shed be? So when they say square feet, even though they didn't say area, I have to know that means area. Okay? So they gave me the area, and they want me to find what's the perimeter. So I need to know what this side is so I can add up all the sides and figure out what the perimeter is. So I know area of a square is side to the second power. So I know that my shed, I want it to be 225 square feet. So I plug that in for the area. That. And all I have to do is algebra. I want to know what one side is, so I have to do the opposite of squaring to get S. So I take the square root. That's the opposite. If I do it to one side, I have to do it to the other. And the square root of 225 is equal to 15. Good. So this side is equal to 15, which means so is this side, right? So is this side.
So you times it by 4.
Exactly. We know that perimeter is 4 sides put together, right? So 4 times 15. So our perimeter is 60, and we're going to say feet, right? Yes, feet. Perimeter is 60 feet. You get that right?
Yep.
Nice. Good job. Okay, let's go ahead and go over number 3 from the practice problems. And so number 3 gives us a survey, right, of all the salmon that people say are their favorite. Jesse took a survey of 100 people, asked them what their favorite salmon are, right? So on your handout, you should see for coho, 22 people said coho was their favorite. Chum, 1 person. Sockeye, 41 people said it was their favorite. And then king salmon, 36 said it was their favorite, right? And so part A for this table says, what is the probability that a person selected at random from the group chose either king or red salmon as their favorite? And it wants us to share our answers as a simplified fraction and as a percent, right? So to figure this one out, we need to know the probability of king, right, and red salmon. And so how I'm going to find this is I got to think, well, how many people said they like king? plus how many people like sockeye. Okay, so I'm going to take 36 people liked king salmon as their favorite. Another 41 liked sockeye. How many total people were there that were surveyed? It told us that there were 100, right? So now I just plug that into my calculator. 36 plus 41 is 77. Divide that by 100, and we get 0.77. But we also need a simplified fraction, right? 77 over 100 is already simplified. So we had to do a fraction and a percent. Remember to change to a percent when we have a decimal. We just have to move it 2 spaces to the right. 1, 2. So 77% of the survey respondents said their favorite was sockeye or king. Okay, so that's part A. What about part B? Based on these results, if Jesse asked 900 more people, how many total people would select chum as their favorite? Well, we have to think about how many people selected chum in our first go around. 1 out of 100, right? And we're saying, what if we had 900 more, right? What if we added 900 more people to our survey? How many would we have? Well, we'd have a total of 1,000 people then, right? So what factor, like what did I change by to get from 100 to 1,000? Isn't that 10 times more, right? So how many people would I expect to like chum? Well, just multiply it by 10. And that would be the total. So it said, the question was how many total people would select chum salmon, right? Based on, if I asked 900 more people, there would be 9 right here and 1 from our original. So 10, whoops. So 10 people total would have selected chum. They must be crazy to select chum as their favorite, but that's what they picked. So that's problem 3. Let's look at problem number 4. You have a box that measures 9 inches wide, 9 inches long, and 9 inches tall. A box where all the sides are the same. That's just a fancy word for a cube, isn't it? Oops. So all the sides we know are 9 inches, right? So see how I just read the first part and I paused, I drew, I'm figuring out what I know. The question is, how many cubic feet of dirt could I fit if I were pouring it inside this box? Okay, cubic feet, they said. How many cubic feet? For us, this has to be a signal word, a signal phrase that tell us this is a volume problem. Cubic units, cubic feet, cubic inches, right? Notice that we have different units here. We have 9 inches that they gave us, but they want our answer in cubic feet. Okay, so it's volume, but it's also, we have to do a conversion. Okay, so what I'm going to do is start off and I'm going to convert 9 inches to feet. So there's 9 inches for how many feet in an inch? Or I'm sorry, how many inches in a foot? 12 inches in a foot, right? So 9 inches divided by 12 will tell me how many feet 9 inches is, because there's 12 inches in a foot. So this is how I do a conversion, right? 9 divided by 12, punch that into the calculator, you get 0.75. So our new cube has a side length of 0.75. It's the same distance, but now we're talking feet, which is what we need for our answer. They want to know how much dirt can fit in cubic feet. It's a volume problem, so I'm going to use the volume of a cube formula that we've always talked about. Volume equals edge to the third power when we're talking about a cube, right? And so plug in what you know. We don't know the volume. That's what we're trying to figure out. So volume equals 0.75 to the third because that is our edge, right? So if we type that into the calculator, again, to do that, you're going to hit 0.75, and then you're going to hit the caret key, and then you're going to hit 3 for to the third power. So 0.75 to the third power. And you're going to get a decimal. So the volume equals 0.421. Okay, so the volume is 0.421, or let's say we said round to the nearest hundredth, so it would be 0.42 cubic feet. All right, so that is problem 4. What about problem 5? Problem 5, you are asked to create a 4-digit PIN to access your debit card account. So remember, think about, you go up to the ATM, right? And there's all the buttons that you have to enter your PIN, right? With the numbers on it. And you have to create a 4-digit PIN. So our PIN has to be 1, 2, 3, 4 digits, right? To access our account. But they have a strange rule, right? Strangely, you could not have any number repeat, right? So this is a probability problem that is a dependent problem, because if this first number is a 4, the second, third, or fourth number can't be a 4 because nothing can repeat, right? So we have to go digit by digit and think about how many options we would have, right? So for the first digit, because the question is how many combinations can you make, right? So the first digit can be any number, 0, right, through 9. So that is a total of 10 digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits, right? But whatever digit we use here, we cannot use here. So here we only have 9 other options left. Whatever digits we've used in these 2 spots, we can't use here. So we only have 8 choices left here. Now we've used 1, 2, 3 numbers. And for our fourth number, we can't repeat, right, any of these. So it's down to 7. So to figure out how many total combinations I can make, I just multiply 10 times 9 times 8 times 7, and I get my answer. So plug that in, 10 times 9 times 8 times 7, and you get 5,040 different combinations that you could make for your ATM PIN. That's problem 5. Lastly, I wanted to give you guys a little fun challenge problem. So let's talk about this challenge problem. It's kind of silly, but let's look at it. John loves math. When his girlfriend asks him how much his monthly house payment is, he tells her, imagine there is a square. John sounds like a real catch. One side of the square, right, is equal to the quotient. Remember, quotient is a signal word that means we have to divide, right? So let's think about this again. Taking it step by step, right? One side of the square is equal to the quotient of 100, the quotient of 100 and 9 less than the square root of 841. The square root of 841, but 9 less than it, right? So 9 less translates to minus 9, right? Signal word less, okay? And then he said, my rent would be equal to the product of the area of that square and 40. Whoa. So this formula here, if you remember, one side of the square is equal to the quotient of 100 and 9 less than the square root of 84. Whoa. This is equal to one side of the square. Okay? And what he said is that his rent would be equal to the product of the area. Well, the area of a square is side squared. But he said his rent is equal to the area of the square, so the area of the square, and 40, the product. Remember, product is a signal word that means multiply. You might have to rewind this problem a couple of times and really think about it, right? So the area, the product of the area of the square and 40 is going to equal the rent. But in order to get the area of the square, I got to figure out what the side is first, right? So I'm going to look at this problem that I got for side of the square, right? So let me change my color here. So what's the square root of 841? Remember, to find square root, you hit second, then you hit the squaring key and you type in the number. Whoops, not 2, 841. So we're going to do that. Second squaring key, 841, gives us 29. Right? 29. I better put this in parentheses too. I forgot to do that. Okay. So it's the, let me rewind a little bit. This goes in parentheses because it says the quotient of 100 and 9 less than the square root of 41. 9 less than the square root of 41 has to go together because of the way it's phrased. That's just a little bit tricky, but that's how it is in this problem. So that's going to be 29 minus, minus 9. Bring down the 9. Okay, divided by 100. Okay, so the quotient of 100, the quotient of 100 and 9 less than the square root of 841. Take the square root of 841, we get 29. Drop everything down, rewrite it, right? That's what I did, and that's going to equal our side. 29 minus 9 is going to be 20. It's in parentheses, so I do it first. That's why it's important for it to be in parentheses. So then we have 100 divided by 20 minus 9, 29 minus 9, which is 20. 100 divided by 20 equals 5. So S equals 5. So one side of our square is 5. Remember, we need to know the area square, the area of the square to find the rent. So the area of the square is 5 squared, right? So the area is 25. So now I just plug in 25 here. And to find the rent, I do the area times 40, the product of the area times 40. So 25 times 40 is 1,000. So John's rent is equal to $1,000, or his house payment is $1,000. Don't forget there's a part B. True or false, John became a single man after this. I would say that's true. Okay, everybody. Thank you for watching, and I hope that this was a good review for you. Maybe you'll have to watch it again, right, to really get these things solidified, or maybe you'll watch it in a few weeks to make sure you remember. So I'm signing out. Thanks for tuning in, and we'll see you for the next review later on.